Hi, this is Mrs. Kidman, and in this video, we're going to be talking about special product patterns of polynomials. So what that means is there are certain times when we multiply polynomials and we end up getting a certain pattern that is kind of interesting to see. So what we're going to do is we're going to discuss some of these patterns that we can use to then identify what happens when we multiply polynomials here. So let's first take a look at this sum and difference pattern. So the sum and difference pattern means that I have two numbers that are the same here. So every time we see AB, what this really means is we're looking at something like x plus 4 times x minus 4. And this is just a binomial is kind of what we're looking at, these special product patterns for. And so if I have a binomial times a binomial, or x plus 4 times x minus 4, where the only difference between the two binomials is the sign, so a sum and difference, what happens is our middle terms actually cancel out, and we end up getting the first term squared minus the second term squared. That's just how it's going to play out for us. Okay, a second special product property is when we square binomials. So what happens if I have the same thing, so I have something like x plus 4 squared, what I end up doing is it follows this pattern of the first term squared plus the second term squared plus 2 times the first times the second. So this one would become x squared plus 2 times the first times the second, which is 8x plus 16. Similarly, when we have a subtraction problem like x minus 4 squared, so that difference of a square binomial, what we get is the same thing, but our sign is whatever matches the middle. So if it's a plus here, we get a plus. If it's a minus, it's a minus. So this one will be x squared minus 8x plus 16. Notice how the last term is always positive. So it's going to be positive, same sign, positive. Now, the last one that we are going to look at here is the cube of a binomial. So what that means is we're looking at something like x minus 4 cubed. And so what that does is it actually ends up giving us 4 parts, but we end up getting 3 times the first one squared times the last one, and 3 times the first one times the last one squared, plus the last one cubed. Okay, so let's take a look at this first one. So our first one cubed is x cubed. And then what we end up getting is we end up looking at this next piece here. So I've got plus 3 times a squared, which is x squared, times b, which is negative 4. So 3, oh, this should be a plus here, a positive 4. So 3 times 4 is 12 x squared. And then we end up getting plus 3 times whatever our last term is. So 3 times 16, or 48 x. And then lastly, we get this b cubed, which is going to be 4 cubed, which is plus 64. Now, very similarly, we get the same thing happening when we have an x minus 4, or the difference in there. The only thing that changes is we get the same sign, the opposite sign, and then the same sign. So in this case, we get same, opposite, same. So we're going to get x cubed. The opposite would be minus 12x squared plus 48x minus 64. Okay, so notice how the numbers stay exactly the same. The only thing that changes between x plus 4 cubed and x minus 4 cubed is the sign that's associated with those two things. So in this case, they've changed there. So let's go ahead and use these special product patterns to identify what things are going to be. So let's take a look at this first one, x plus 7 squared. Well, that's going to be the square of a binomial. And so we know that that's going to be the first term squared, which is x squared, plus 2 times the first times the second, which is 14x, plus the last one squared, which is 49. Similarly, we can do the same thing looking at a problem like this one. This one's going to expand out. And remember, it's going to be our first term cubed, plus, when it's a plus inside, remember, these are always going to be pluses. In this case, where it's a minus inside, we're going to do that same, opposite, same. And so we've got x cubed plus 3a squared b. And then we also have a 3ab squared. So 3a squared b, we've kind of done this problem already before. So we get 3 times x squared times 4, which would be our 12x squared, plus our 48x plus 64. Now let's take a look at this next one here, x minus 6 cubed. So in this case, we're going to get x cubed. Then we have the same sign, which is a minus, and we're still going to do this 3a squared b. So that means we get 3 times x squared times negative 6, which is actually going to give us a minus 18 x squared here. And then our next sign will be the opposite, so a plus, and that's when we're going to do that 3ab squared. And so our b squared is 36, and then 36 times 3 is going to give us 108. So we end up with 108x. And then lastly, we get that 6 cubed, which gives us a minus 216 because it's going to be the same as the sign in the middle. Awesome. And then this last one here, we have a binomial times a binomial. But notice how it's the same, opposite sides, same answer. So what that means is it's really just going to be these two times those two, plus those two, or minus those two, I guess. 2x times 2x is 4x squared. 6y times 6y, well, the opposite signs give us a negative 36y squared. Perfect. So that's how we can use those special product patterns to help us identify what those different patterns are when we multiply some binomials, and how knowing those patterns will help us in expanding out that knowledge that we need. So again, those are some of our special products that we can use. You can always just multiply it out like we talked about in the last video. However, if you are interested in using these special product patterns, they can be really useful and they're good to be aware of, especially when we start doing factoring, where we're given a polynomial and have to go back into this multiplied form. As we do that, it's really nice to be able to say, oh, this one is a special product because of this characteristic of it, so I know exactly what it's going to look like, instead of having to go through the factoring process, which is really handy. So keep that in mind as you are working these out to make sure that you recognize some of those special product patterns, because we really have those patterns and they're special and important and good to use so that we can make our math function a little bit easier. If you have any questions, feel free to reach out. But again, that is how you would use special product patterns to multiply polynomials, specifically binomials in this case, whether you're squaring them, cubing them, or finding the sum and difference.